So this question says that the diagram shows an open container in the shape of a cuboid of width x centimeter, length 4x centimeter, and height 8 centimeter. Okay, notice that it says open container. So this is an important information. We'll come back to it in a bit. Okay, the volume of the container is 800 centimeter cube. Okay, so the volume is 800, which means length times width times height, whatever you call length, width, height, okay, equals to 800, which gives us 4x square h is equals to 800, which gives us x square h is equals to 200, and we could make the h the subject, 200 upon x squared. Okay. Show that the external surface area of the open container is such that, okay, so this is going to be the surface area of this open container. Okay, surface area would be sum of all areas. So we're going to find this area, double it, and then we're going to find this area and double it, and then we're going to find this area, but we will not double it because it's open from the top. Okay, let's find all the areas. We have 4x squared for the bottom one. Then we have 4xh for this one times 2. Then we have x times h times 2 for this one. Okay, now this becomes 4x squared plus 8xh plus 2xh. This is the surface area that we're getting. However, in the surface area shown here, they have not included h. That means h has to go. And how does h go? Through this equation. Replace h with 200 upon x squared. There's also an x. It was supposed to be 8xh, but anyway, plus 2 times x times 200 upon x squared. Okay, what does this give us? Okay, so we get 4x squared plus we get 1600 upon x, and we get 400 upon x. We can add these two fractions. That gives us 4x squared plus 2000 upon x equals to the surface area. And we have proved the required equation. Okay. Next it says that given that x can vary, find the stationary value of s. Okay. So stationary value of s, we already have the equation for s. It is, let me write that again, 4x squared plus, instead of writing 2000 upon x, I'm writing 2000 x power minus 1. It's the same thing. Okay. Find the stationary value of x. Stationary value means it's either going to be a maximum value here or maybe a minimum value here. But we know that if it's a stationary value, then the derivative is going to be 0. And derivative in this part would be ds upon dx, not dy by dx, but ds by dx. Okay, let's find the derivative and equate it to 0. We'll get 8x minus 2000 and x power minus 2 because the power gets reduced by 1 and equate it to 0. Now let's solve it. 8x minus 2000 upon x squared equals 0. That gives us 8x cubed minus 2000 upon x squared equals 0. 0 and x square get eliminated, so we have 8x cubed equals 2000. because minus 2000 goes to the other side, this and this gets multiplied and gets eliminated. Okay, we have x cube equals, what is 8,000, 2000 divided by 8? It's 250. And then we cube root 250 to get the value of x. Shift cube 250. It's coming out to be 6.2996. Okay, so this would be the value of x uh, at the stationary value. Okay, that means, for example, if this is the stationary value, then the value of x here would be 6.299. Okay, it says, given that x can vary, find the stationary value of s. So we found x, but the question is asking for s. That we can do easily by substituting this x here. So it's going to be 4 times 6.2996 squared plus 2000 into 6.2996 power minus 1. Let's substitute that. I'm going to do 4 times answer squared plus 2000 times answer bracket power minus 1. Oops, I did minus 4. I'll have to redo this. 4 times 6.2996 power squared plus 2000 6.2996 bracket power minus 1. No mess up this time, please. Okay, now I got a syntax error. Let me pause and do this properly. Okay, after entering it in the calculator for the third time properly, I got the right answer. S equals 476.22. So at the stationary value or at the stationary point, the first value you get is the value of x. And then the question was asking for the value of s at this point. So that would be by substituting 6.2996 in the equation for s. That gives us the value of x. And lastly, it says, and determine the nature. So you have found a stationary value. So it could have been this value where the graph is maximum, or it could have been this value where the graph is minimum. So what is it? Is it the maximum? Is it the minimum? So for that, we're going to use the technique that we learned in the class. How do we tell if the stationary point we got or the stationary value we got is maximum or minimum? You first need the first derivative again, which I believe was this. Let me write that again. So we have the first derivative, 8x minus 2000 x power minus 2. Derive it again, take its second derivative, which is d square x upon dx square, and it becomes 8 plus 4000 x power minus 3. So after taking second derivative, now substitute the value of x that we got, that was 6.2996, and see if you get a positive answer or a negative answer. Okay, so I'm going to do 8 plus 4000 bracket 6.2996 power minus 3. I'm getting exactly 24, which is greater than 0. So if it's greater than 0, that means the stationary point is a minimum. Hence, minimum. Achha, let me try to explain this graphically. So you have, the question is done by the way. Okay, so you have an x-axis and sorry, you have a y-axis, which is s, and you have an x-axis. So you probably get a minimum point somewhere in the curve. So they first made you find the value of x at the minimum point. We didn't know it was minimum back then. We just knew it was a stationary value. So first you got this value, by equating the derivative to 0. So this came out to be 6.2996. Next, they asked for the corresponding value of s that we got by plugging in the value of x in the equation of s, and that gave us 476.22. So this is a stationary point that we get 6.29 comma 476.22, okay, whatever. And in the last part it says that explain whether this turning point or stationary point is a maximum or minimum. So for that we double derived it. This was the first derivative, this was the second derivative. In the second derivative you have to substitute the value of x of the stationary point. That came out to be 6.29. And now uh, by after taking second derivative and equating the x of the stationary point in it, we got a negative value, which sorry, we got a positive value. It was 24, which implies that this stationary value is a minimum.